Hi, my name is Darshan and I'm an online tutor of math and physics. This is in continuation to our series of videos which we were making on AP Physics 1 2023 FRQ. This is question number 3, the easiest question in the complete AP Physics 1 2023 paper. This is the easiest and it will hardly take 5 minutes to solve this question if we know about the concept. This is based on circular motion and some spring forces. Let's read this out. A small block of mass m0 is attached to the end of a spring of spring constant k0. So we have the spring constant k0. This is where we have a small block of mass m0. So this guy is, okay, just one second. Yeah. All right. This guy is m0. This is k0, and this is on a horizontal table, and a rod is attached to a motor that can rotate at various speeds because there's a motor to it, so it can rotate at various speeds about its own axis. When the rod is not rotating, obviously the block is at rest and the spring is at its unstretched length L, so this is its natural length, and all the frictional forces are negligible. That's a relief. At T1, one scenario is given. So at time t equal to T1, the rod is spinning such that the block moves in a circular path with a constant tangential speed V1. So its tangential speed at this instant is V1 when it is rotating at some angular speed which we do not know, but we know that its stretch from the natural length is D1. Likewise, in figure 2 over on the right side, at time t equal to T1, the rod is spinning such that the block moves in a circular path with again a constant tangential speed V2, which we again with an elongation of D2, and once again we do not know the value of omega, but there is some omega, some different omega, which we for sure, which we know for sure it's different. We know that D2 is greater than D1, fair enough. So the question one says, I'll just try to zoom this in since we are through with these two images. Let me zoom this size a little bit. Yeah. Now they are saying that on the following dots, which represents the block at the location shown in the figure 1 and 2, draw the force that is exerted on the block by the spring at the time T1 and T2. The spring force must be represented by a distinct arrow starting on and pointing away from the dot. Relative lengths of the vector to reflect the relative magnitude of the force is exerted by the spring at both the time measure. So it means that we have to draw, in other words, we have to draw in a force exerted by the spring in situation 1 and in situation 2, keeping in mind that their relative position matters. So we have to show that which one is high and which one is higher force and which one is the lower force, which is pretty straightforward. Why? Because what is the spring force? If you can remind me, what is the force of the spring? Force of the spring is of course kx, right? And what is x? X is not the total length, please mind it. X is only the stretch. So in case 1, the stretch is d1. In case 2, the stretch is d2. The value of k is k0, and it's already given in the question that the value of d2 is greater than d1. So this makes perfect sense that between fs2 and fs1, obviously fs2 should be more because k0 is same in both of them and d2 is greater than d1, so fs2 is greater than fs1. So all we have to do is draw two vectors, and of course where is the direction? Whenever the spring is stretched, the spring has a pulling tendency, so the force in both the directions will, in both the cases, will be over here, over on the right side. So I'm gonna draw, maybe starting right from the center, I will draw, let's call it 1, 2, 3, 3 units on the right side in case 1, and then the right one I'm gonna make 1, 2, 3, 4, maybe 4 units on the right side. The idea behind 3 and 4 is just to indicate that the right one is obviously a greater force than the left one. That is the only idea. So it should be very crisp and clear in our drawing to show that we are clearly showing that there is a difference in the relative lengths of both the vectors. That was pretty straightforward. And the next question, they are talking about referencing d1 and d2. Describe your reasoning for drawing the arrows the length you did in part A. So actually we already did that right over here, right? The work in the white one, that is the description for part 2, that since force of the spring is given by K naught times X naught, so Fs1 is K naught D1, Fs2 is K naught D2. I'm just writing officially over here once again. Since D2 is greater than D1 implies that Fs2 is greater than Fs1, and that is the reason. Remember that AP Physics 1 is really picky about the way you write. The rubric is very important. So you have to show this work very clearly, that why you think that Fs2 is greater than Fs1. So this is the way you show the complete work. Okay. Now, is the tangential speed v1 of the block at time t excuse me, at a t1 greater than, less than, or equal to the tangential speed as at v2, and justify your answer without using equations. I think it's pretty intuitive, right? v2 should be greater than v1 because the d2 is more, but remember that we cannot use any equations. So without using equations, I think I can say that the velocity v2, okay, we know from the above part that Fs2 is greater than Fs1, right? We know that. If the force is more, and we know that force is proportional to acceleration because the mass is constant, right? So can we say that the acceleration in S2 is greater than acceleration in S1? You might be wondering, why am I writing all this in the form of equation when they are saying without equation? We do not have to write equations, but all this which I am saying should be written in a coherent paragraph. I'm writing equations to make you understand. Let me write the equations first, and I'll tell you how we should have written that in the actual exam. So acceleration is more, and don't you think if the acceleration is more, obviously it makes sense that the velocity should be more, or angular acceleration or angular velocity, everything leads to velocity being more. So this is a very straightforward description without using an equation. So the way you're going to write is since force on situation 2, or maybe the figure 2 is greater than figure 1, this implies that and we can say that since as per Newton's law, Newton's law or Newton's second law, since force is proportional to acceleration, or maybe once again you can write an equation, a sentence over here, phrase over here, since force is proportional to acceleration, this means that this would indicate intuitively that this implies that acceleration of 2 is greater than acceleration of 1, which also implies that v2 is greater than v1, right? So this is how you can explain this in a coherent paragraph. I hope this makes sense. And the next question, they're talking about, consider a scenario where the block travels in a circular path where the spring is stretched a distance d from its unstretched length L. Determine an expression for the magnitude of the net force F net exerted on the block. Express your answer in these terms. All right, so that's pretty straightforward, because they are asking to find the net force exerted on the block, and the net force exerted on the block is nothing but K times, in fact K naught times X, right? And what is X? X is just the stretch, so K naught times D. That's it. That's the answer. Determine the expression for the magnitude of the net force exerted on the block. That's it. Because the spring force is the only force which is being exerted on the block. We can go back if you want to see the image once again. This is the block. Only the spring force exerts on it, which is a pulling direction. So it's just K times x naught, where x naught is the stretch. Stretch is d, so it's just k naught d. Write an equation for the tangential speed v of the block and express in this terms. Okay, so now we can say that the force which is exerted towards the center, the centripetal force, is equal to m naught v square over r, where we need to find the value of v. Now fc is already given as k naught d, m naught is m naught, v is unknown, and r, be careful, r is nothing but, in fact I can draw a new image over here rather than doing back and forth. This is the pivot, this is where, in fact this is the mass, this is not the pivot, this is the mass, this is the spring, this is where it is being connected to a rod. Remember that its natural length is L and the stretch is D. So the radius will just be, I mean this is spring all over, the radius will just be, radius will be the sum of D and L, right? The total length. So this is what we have to be careful about, that this should be D plus L. A little bit of rearrangement, multiplying d plus l both the sides, so k naught d plus l is equal to m naught v square. Dividing both sides with m naught, we have k naught over m naught d times d plus l is equal to v square, which means that the value of v is going to be square root of k naught over m naught d times d plus l. So I just took square root both the sides. So this is our expression in terms of m naught, k naught, l and d. There is no other variable as indicated in the question, only those variables. And the last question, I think, is, yes, this is the last question. Does your equation for the tangential speed of the block from part B agree with your reasoning from part A? What was our reasoning in part A? We were saying that since the force is more, acceleration is more, so the velocity is more. And let's see if the math agrees with us. So using this equation, can we say that if this d is more, because remember d is the only variable over here, k naught is fixed, m naught is fixed, l is fixed. So obviously it makes sense that if the value of d is even more, the velocity will be even more. So more is the value of d, more is the velocity, and this 100% agrees with our interpretation earlier. So just explain your reasoning. I just explained that since the velocity is proportional or not proportional, yeah, you can just write that since velocity is equal to root of k naught over m naught d times d plus l, and increases the value of d since the other parameters are constant. Since the other parameters are constant, will increase velocity. Since the value of d2 is greater than d1, this implies that v2 is greater than v1. Pretty straightforward. I hope this video makes sense. If this video was helpful to you, please subscribe to my channel. Take care. Bye-bye.